Hello everyone, welcome back. Today we are going to start with a new chapter, new concept, coordinate geometry. But before we begin coordinate geometry, let me ask you a few questions. We know how to represent a point on a number line or a number on a number line. That we have done. A number line, it extends indefinitely in both the directions, the positive and the negative, the neutral number being 0. To the left of 0, we have all the negative numbers, and to the right of 0, we have all positive numbers. What are these positive and negative numbers? They are known as directed numbers, as they indicate direction. As I told you, to the left of the number line, we have all negative numbers. To the left of 0, if I take 0 as the central point, and to the right of the 0, we have all positive integers. So 0 is a neutral number which is neither positive nor negative. So just remember that in mathematics, the sign, they indicate the direction. So far we have learnt how to represent a point on a number line. If I make any point over here, if I mark a point here, it will represent -2. If I mark a point here, it will represent +4. If I want to represent a point, I will take the help of a number line. Okay. But what if I want to locate a position? If I want to locate the position of a point, this is placing a point on a number line. So if I have a single number line, on a line, if I represent a number, either to the left or to the right, I will take the help of a single number line. But what if I have to represent a point on a plane? If I have to represent a number line on a plane, then along with these horizontal number line, I would require a vertical number line. And how is this vertical number line formed? This is formed by tilting this horizontal number line in the anti-clockwise direction. If I just imagine tilting this horizontal number line in the anti-clockwise direction, it will become a vertical number line, and all the positive values will come on the top and all the negative values will go down. So we name this vertical number line as a different number line. My horizontal number line is denoted by a variable x and x dashed. X dashed. It represents horizontal number line, and which we refer to as the x-axis. Y dashed is my vertical number line, and we refer to it as y-axis. So if I have to locate the position of a point on a plane, I will take the help of the horizontal as the vertical number line. As I can see, the horizontal and the vertical number line, they divide the plane into 4 regions, and this plane is known as a Cartesian plane. And this plane is known as a Cartesian plane. The Cartesian plane consists of a vertical and a horizontal number line and divides the plane into 4 regions or quadrants. So this is since I have moved the number line in the anti-clockwise direction, the first region or the first quadrant is this. This is the second quadrant. This is the third quadrant, and this is the fourth quadrant. Remember, we have to move in the anti-clockwise direction. Now, if I have to locate a point on a number line, we know how to do it, but how to locate a point on a number line, or how to locate a point in a Cartesian plane? Suppose I take a point here. Then what will be the value of this point? If I locate a point on a number line, it was given by a single variable, but here it is on a plane. When I am talking about position, I am talking about the distance of the point from the x and the y axis. So if I look at this point carefully, in the first quadrant. In the first quadrant, if I look at this point carefully, this particular point, how far it is from the x-axis and how far it is from the y-axis, this will give you the position of the point. As I can see, this point is 2 units away from the y-axis. It is 2 units away from the y-axis. So the distance of the point from the y-axis, how are we measuring it? We are measuring it in terms of x, the distance travelled along the horizontal line. Only when I travel horizontally, I will be able to find its distance from the vertical axis. So first I will write down how far it is from the y-axis. Now let us see how far is this point from the x-axis. It is 4 units away from the x-axis. So what do we see? That the vertical distance gives you the value of y and the horizontal distance gives you the value of x. So the position of a point is written, it is written in the form of an ordered pair. It is written in the form of an ordered pair. And what is that ordered pair? Why do we call it an ordered pair? We know we call it a pair because it gives us the position of x and the position of y. The first is the position, how far it is at a distance from the y-axis, and the second number, it refers to how far it is from the x-axis. So it is called an ordered pair because we are representing this position or point with the help of 2 digits. It is known as an ordered pair because we write down the distance from the y-axis, that is the value of x first and the value of y later. Since it is written in a particular order, we call it an ordered pair. Now what do we call this value of x technically and the value of y technically? Technically, this x is referred to as abscissa and y is known as ordinate, and together they are known as coordinate. And from here we know that what are we studying and why do we call it coordinate geometry, because throughout the chapter we will be dealing with this ordered pair, which consists of the coordinate, the x ordinate, abscissa, and the y ordinate, that is known as ordinate. Now we know now what is an ordered pair. So each quadrant will have an ordered pair. In the first quadrant, if I choose any other point, suppose I choose this point. Suppose my first point was A and this point is B. If I choose another point B, I can see that the ordered pair is 1, 5. The distance from the y-axis is 1 and the distance from the x-axis is 5. So if I choose any other point, I will get an ordered pair. But what is the peculiarity of all the points in this quadrant? In the first quadrant, I observe that the value of x as well as y both are positive. The value of abscissa as well as ordinate are positive in the first quadrant. In the second quadrant, if I choose any point, the ordered pair will be -3, 1. So what do we see here? In the second quadrant, the value of x is negative and the value of y is positive. In the third quadrant, if I choose any point and just look at the number line, we are in this quadrant, we are taking the negative part of both the number lines. So what will be the ordered pair here? The ordered pair here will be -3, -3. So both x and y are negative in the third quadrant. In the fourth quadrant, if I choose any point, the value of x will be positive and the value of y will be negative. So this is basically the concept of 4 quadrants and the ordered pair and the sign of the ordered pairs in each quadrant. Moving forward, the 4 quadrants, as I have already told you. Here, as I can see, the value of x and y, the abscissa and ordinate, both are positive in the first quadrant, and x is positive and y is negative in the fourth quadrant. And if I move along the horizontal number line, as we move to the right, we move to greater value, and as we move to the left, we move to a smaller value. Similarly, for the vertical number line, as we move up, we are moving to a greater value, and as we move down, we are moving to a lesser value.
To watch the complete video, download the Upbind educational app from Play Store and App Store.